Welcome to Medical Matters Weekly with Dr. Trey Dobson, presented by Southwestern Vermont Healthcare and Catamount Access Television.
Today is October 12th, and we are recording for our October 19th show. Welcome, everyone. I'm Trey Dobson, Chief Medical Officer at Southwestern Vermont Medical Center and an emergency medicine physician with Dartmouth Health. And this is Medical Matters Weekly, a show about the aspects of healthcare that matter to you most. My guest today is Dr. Mariella Philbin. Mariella, welcome to our show.
Thank you so much for having me.
Did I pronounce your name correctly?
Perfect. One of the few.
Well, I had a little help ahead of time. Dr. Philbin is a leading researcher working towards cures for pediatric brain tumors. That's what we're going to be talking about today. Should be a great show. A little bit about her background, and the rest of it is on our website. She's the co-director for research for the Pediatric Neuro-Oncology Program at Dana-Farber Cancer Institute and Boston Children's Hospital, although she tells me she likes to come to Vermont to ski, so that's fantastic. And the co-director of the Brain Tumor Center of Excellence at Dana-Farber Cancer Center. She earned a medical degree and a PhD in biochemistry and molecular biology from the Medical University of, is it Graz?
Graz, that's right.
Graz, Austria. So again, welcome. Where are you right now, Mariella?
Thanks so much. Yeah, so I'm right now in my office in the Longwood area of Boston. I'm right in between, basically looking down at Boston Children's Hospital and Dana-Farber on the other side. And the building I'm sitting in is a pure research building, but I'm just steps away from where my patients are.
That's great. But you're not from Boston, correct?
That's right. I'm from Austria, hence the strong skiing background. And I love Vermont for skiing, among other things.
That's great. And before we get into this, you ski. What else do you do for fun?
I'm an outdoorsy person in general. So, like to swim in the ocean, like to hike, like to ski. Whatever, brings me closer to nature so I can get some inspiration, also peace. That's really awesome. And I have a family with 2 little kids. So my husband and the kids and I, we are often found outdoors somewhere, chasing birds or fish.
Which is so important for our well-being. And, in fact, we really can't practice medicine with a straight face if we're not taking care of ourselves, right? That's so important.
It's so true. I walk to work also every day, which is a little bit more unusual here, I guess, but it's more common in Austria. And it's a 2.5 miles hike one way. But I just love it. And it makes all the difference for thinking about my research, thinking about my patients, just making sure it's all ordered in my brain.
It's funny you bring that up real quick. I think that is so important. I think a lot of people do as well, but they can't find the time, or they don't feel like they can find the time. And I am the same way, and I live very close to work. But what I have done is said, okay, let me just pick out a few days and make those days work. And I think that's just a good way to start. So if those in the audience are thinking about the benefits of walking, but no, they don't have time to do it, outside of work, they can make it by walking to work, or at least walking a good distance. But that's so interesting. We can talk about that later. We're going to go into your research now. So how did you get interested in medicine while you were growing up in Austria?
Yeah, when I was growing up, I should say I come from a non-medical family. So my whole family are farmers and teachers from the countryside, really, in Austria. And I was always fascinated by humans. My mom and my grandma were very integral in the village I'm from, they were basically like the psychologists, even though without training for the whole community. And so I found myself often going with my mom to hospitals, to visit new babies, or also like end of life, people. And that just really stuck with me. And I just was fascinated by what's happening in those hospitals, and always saw myself as working in hospitals. So I started with a pure MD. I thought that's where I was going to be. And in Austria, you start at 18. And I was, bright-eyed, thinking, oh my gosh, I'm going to learn all the beautiful, amazing magic of medicine. But then realized pretty quickly that so many answers were not present, or there were so many questions without answers. And so I asked professors over and over again, but how does this work? Or where does this come from? Or, how did you find this medicine even? And oftentimes the answer was, well, I just don't know. Until one professor said, I don't know, but how about you come to my lab and try to find out? And I thought, well, that's interesting. What's a lab even? Again, I didn't have that background at all in my family, or didn't know anybody. But that aspect or his approach was just fascinating to me. So I joined his lab, not knowing what I was going to get into, and just loved it. I loved how, there were questions we could ask, like big questions, small questions, how we could work on the answers, and then just the whole lab environment and how that then would translate into medicine then again. So coming full circle just really fascinated me, and yeah, has never left me since then. It is only growing bigger as I've grown older.
So for some of you in the audience, when I say pediatric neuro-oncology, let's just make sure we all are coming to this from the same background. There's a pediatric, so kids, neuro, brain, oncology, cancer, and the study of cancer. So these are specifically cancers that involve the brain or the spine or nerves in general, and then focused in a pediatric population, which is going to be quite different generally than the types of cancers that develop in adults, because they develop for different reasons, which of course Mariella can go into. But tell us, so you're interested in medicine there, you figure out what a lab is, but most people don't say, aha, I'm going to go into pediatric, and not only pediatric, I'm going to go into neuro-oncology.
Yes, exactly. And it was all based on a little girl. I think that's many of how many of the stories start. I was a young medical student, again, going to the wards, and there was this little girl, I'll never forget her. And I learned she had a tumor called DIPG, or diffuse intrinsic pontine glioma. I knew nothing about this disease at the time, of course, and again, was still in this very almost like naive thinking of, oh, like medicine can cure everything. And then when I asked like what this tumor was and what we were going to do to treat her, I just heard that there's nothing we can do. And I said, what do you mean there's nothing we can do? And that stuck with me so much. Thinking that we're, back then, that's 20 years ago now, but still, like in modern times, there's nothing we can do for a little girl. And that she was gonna die of this disease was just I just could not deal with that fact, and I couldn't accept it either. So I went back to the lab and to my professor back then and said, you know what, that's what I want to work on now. Like, that's impossible that we can't find a cure. We can fly to the moon. And actually, for a fact, Neil Armstrong's daughter, so the first man on the moon's daughter, died of DRPG, so that same tumor. And the treatment back then, when she was treated before he flew to the moon and when she passed away, and now is almost the same. So that was a fact that I just could not just take, for granted. And yeah, since then I've been working on this disease and many other terrible tumors where we don't have answers yet. And I do believe we'll change that in my lifetime.
Your story is so powerful. And actually, for those who are not in the medical field, it's actually fairly common. We think of doctors and nurses, having this lifelong dream always to go into the field, but many are spurred on by one event, whether it's a family member or just some event that really impressed upon them and caused them to have motivation and inspiration, towards all types of healthcare. What makes brain tumors, cancers in neuro tissues more difficult to treat, study in the pediatric population? This is a little bit of a loaded question than perhaps some of the other childhood cancers that we've known about, like leukemias and others.
Yeah, there's multiple issues. One of the issues with brain cancer in particular was that for the longest time, people wouldn't really touch them because the neurosurgical techniques were not quite, as advanced yet. So we knew some of these patients, or many of those patients, would die regardless of what we did. So the thought was more like, let's not even, have the kids undergo a surgery that could be devastating or could, cause more harm than benefit. And so for the longest time, especially for this DIPG, this midline tumor, but also other tumors like glioblastoma, we didn't know what those tumors were made of. They looked the same, on magnetic resonance imaging or CT scans. And when they started biopsying, they looked the same under the microscope, the same meaning as to the adult compared to the adult tumors. But it took a really long time to start genetic analysis of the pediatric tumors. And then sure enough, we found that they were super different. Like the genetic mutations or what drives cancer in kids is very, very different from what drives cancers in adults. And that has many implications because it not only means the classifications are different, it also means that the origin is different, but it also means we have to treat them differently. We can't just take, drugs from adults and assume it will work in kids. And sure enough, many of the clinical trials we did in children, did not work because they were based on, adult tumor types and not specifically tailored or targeted towards pediatrics. So that's one of the issues. And I think the second issue, even though you could say it's a bad thing or a good thing, in adults, cancers oftentimes come from a lot of environmental exposure plus genetic insults, meaning the cancers are pretty messed up. There's a lot of chromosomal issues, there's a lot of mutations, a lot of things going on. In pediatric cancers, they're often very quiet on the genomic landscape. What that means is if you look at the chromosomes, some of them are completely, they look normal almost, the cells, the chromosomes of the cells. And sometimes we just find one mutation or a few, much, much less than in adults. And so the tricky part then is it's still a cancer and it's aggressive. How can it get to that without being so messed up as the adult ones? And I think we're starting to find a few of these answers now, and also then the therapeutic implications of what that means.
So talk to us some about your lab then. You've said that the pediatric oncology is studying some of the last frontier in pediatric cancer, and your lab is doing a lot of work. In fact, this is just a great example of why laboratory bench science is so important to understand a medical condition and then translate that eventually into treatment that works. But anyway, I don't want to cut you off, so tell us a little more about your lab.
Yeah, so last frontier is actually a word or a phrase I want to pick up on. I'm saying last frontier sometimes because I feel like we haven't really made a dent in this disease in a really, really long time. That's what I really mean by that. In leukemias, which are the most common cancer in children, they were deadly many, many decades ago, but now, like through multiple clinical trials that also started at the Dana-Farber and other centers, we can treat our patients very well, like up to over 90%, depending on the leukemia type of patients will survive their leukemia. And so even though it was dreadful many, many decades ago, now it's getting better through the work of many, many people in the field. In brain tumors, that slope of progress just hasn't been as steep at all as we would like it. So that's what I mean by like the last frontier, and also in terms of complicated to treat or just resistant to anything we do, radiation, chemo. Brain tumors just are notoriously known for that. And I feel oftentimes if we could crack that stone, we will crack so many other stones along the way, because we will solve like a lot of these big issues all at once. So then I should go into the lab more probably.
Right. You mentioned, the leukemia of the 60s and 70s, the pediatric leukemia. Actually, for those in the audience, I can't think of any titles right now, but if you go back and you do some research and read fascinating stories about St. Jude's Hospital down in Memphis and some of the other areas, and Boston as well, and the success was enormous and really promising, from a deadly disease to almost a chronic or treatable disease. And I assume that is also what you were trying to do with your with neuro-oncology.
That's exactly what I'm trying to do, and it's an interesting comparison because Sidney Farber, who is one of the fathers of our institute here, he was the first person who had leukemia survivors. And he believed in treating leukemia patients with chemotherapy for the longest time, but that was very controversial at the time, and many people thought he would do more harm than benefit. But he believed in it so much until he had the first survivors. And I feel, having been trained here, I hope this is going to happen to brain tumors as well, where maybe now some people think we're not crazy, but overly optimistic. But I do believe that at some point we will crack that stone and like really, really make some progress towards making it a chronic disease or even cure. So we'll see. In my lifetime is my guess.
Oh, that is fantastic. I'm going to read off a term here. Your lab works with single-cell transcriptomics to determine the tumor architecture and heterogeneity. I just read that straight off of my papers here. Tell us what that means and what your lab is doing.
Yeah, so when I trained here at Boston and Dana-Farber, we had mandatory research years, which is, of course, what I love. So I was waiting for those research years, but hadn't decided where to go, to which lab. And one of my mentors here said, how about you just go to MIT? They do like super amazing engineering stuff. Maybe you can learn a new technique and then bring it back, over to the medical side and apply it to patient samples. So I went to MIT with that, thought process. And sure enough, how, serendipity plays into so much of what we do. I walk into a lecture hall where two professors were giving a talk about single cell transcriptomics. I heard that talk and thought, okay, this is it. This is what we have to do. And what it means is that you look at every single cell within a tumor rather than, at the tumor as a whole. Like instead of grinding up a tumor piece, I know that sounds a little bit gross, but instead of grinding it up and sequencing the soup that comes out, you sequence every single cell with the thought that maybe the answer lies in the subtle differences between the tumor cells and the normal cells that are mixed in there. And sure enough, being trained by leukemia doctors also, I always had this thought in my mind of, oh, in leukemia, we started to get ahead of the disease once we knew the normal stem cells, where these leukemias came from. Could it be the same for pediatric brain tumors? And I thought, if I sequence single cells within each of the tumors, maybe I'll find that stem cell that drives the whole thing. And if I knew what that cell was all about, I could hopefully target. And so I adapted the methodology, the single cell sequencing, to very precious brain tumor samples from here, out of the OR. And sure enough, we found that in DRPG, there are those cancer stem cells that are very immature. They look like almost normal stem cells. But then there's also cells, cancer cells, that seem to normalize almost to normal, as if there are bad guys in the tumor that are bad and divide and destroy. But about a third of those cells, have not a thought process, but think, oh, I was supposed to be a normal brain cell. How about I try to be that and kind of rehabilitate themselves in that way and stop dividing, and then just go on and mind their own business and don't destroy anyone anymore. And that happens without treatment. So this is from patients at diagnosis, no treatment yet, with the huge implication to me now, okay, if a few cells, a third, can figure out how to be not that bad, and figure out how to just mind their own business and stop destroying, can we push all the cells that way? And that way, can we make it into a chronic disease rather than having this thought of like we have to kill every single cancer cells, but leave the normal cells, alone, which is probably very hard to do in a normal brain.
Boy, that really goes against conventional thinking. We think of, first off, a cancer, a tumor, a collection of all cancer cells. We don't think of or at least, conventionally, that there are intermixed, non-cancerous cells or normal cells, as you mentioned. But it must be that communication between the normal cells and these immature cells that go on to replicate uncontrollably, and they're communicating through different neurotransmitters, which I'm sure is exactly what you're studying or something similar to that in your lab, and trying to figure out what communication gets those cancer cells to kind of almost revert back. Is that how you're thinking it?
Exactly. That's exactly right. And indeed, those cancer cells, they're very tricky or, sneaky. They communicate with the normal cells around them, but almost hijack normal processes. So each time you're, activating a neuron, you're thinking or you're moving your arm, the cancer cells get a growth signal out of that. So they have learned to, move close to normal neurons, normal nerve cells, and get stimulated each time you think or move. And the same is true for like normal astrocytes, for normal oligodendrocytes, and for normal immune cells. So this huge new field of immuno-oncology has also not quite made it into brain tumors yet, even though the first papers are now starting to come out, where we're learning that actually the immune cells want to attack, but there's a few signals that prevent them from really killing the tumor cells. And now the thought is like, what can we do to block that, that don't eat me signal and let them go like, fully blown against the tumor cells. So a lot of possible applications, and the first ones are now moving into the clinic, which I'm really, really excited about.
All this is so promising. On the flip, you do see sad situations. You see tough things, and you still see patients, correct?
Yeah, correct.
Yeah. How do you deal with that?
It's a great question. And, once I started having kids, everything became even harder. Mm-hmm. One of my female mentors told me, Mariella, once you'll have kids, you'll be a better oncologist, but a worse mom. And I didn't quite know what she meant until I had my kids. What she meant by that, and what I'm experiencing is you see yourself in many of the situations, right? You see your children in those children, and you see yourself as a mom sitting there with you. And it doesn't get easier at all over time. It gets only harder because, again, when I think back to 20 years ago when I started in the field, I thought we already had all the answers 20 years later, which is now. And we have a few, but not quite, as many as I thought we should or would have. So this pain never goes away. And it motivates me, though, to come back to the lab. And I even take people from my lab with me when I round on my patients, just so that they see why we're actually doing this. This is not for papers. This is not for grants. This is because we want to have a true impact on our patients. And if we don't do it, nobody else will do it. Like, we'll have to do it. I feel very, very strongly that that's my life's mission, my career's mission. And so even though it hurts, it's very important for me to continue to do that despite the pain.
You said that so eloquently. It is true. In order to continue in healthcare, in any field in healthcare, really, but maybe in particular some of the diseases that can lead to death, you have to be motivated, inspired by why we went into medicine in the first place, which is to limit suffering. We're going to see suffering. We have to be compassionate. If you lose that compassion, then you should stop practice. But at the same time, you can't be lulled into anxiety and despair. You have to see where the hope is. And you do it in both ways. You do it as a bench researcher and then also as someone seeing patients. And that is fantastic. And I also want to make sure we leave a little bit of time here because you also have another passion, and that is research funding, fundraising, philanthropy, and how important that is to not only pediatric oncology or neuro-oncology, but other aspects of medicine. So can you just talk a little bit about that so the audience understands?
Yeah. I'm very passionate about this, first of all, because I want to bring families in to really know what's going on an everyday level, in my lab, in the labs around the country. And I'm very happy that I'm co-chairing the next big pediatric neuro-oncology conference here in the United States in 2023. So it's our biggest national conference. We want to bring in parents, advocates, nurses, of course, MDs and researchers to all learn about what's new in the field and how we can think together to really, increase our impact. And what I learned, the hard way also is that everything needs funding. And the traditional funding mechanisms, especially federal funding, oftentimes lags behind for pediatric cancer. And the arguments are, well, there's not so many patients affected if you compare that to breast cancer patients or colon cancer patients or stroke patients, all of whom are of course very important, but then in terms of numbers, pediatric cancer lags behind. And then the priorities, of course, the priority scores for the impact that you might have are downgraded. I think it's changing slowly, but it's changing because of advocates and moms, like Kathy Arabia, coming to the table and saying, but this is really important. Like, every single child we are losing, every single child that is suffering is one too many. We have to change the field, and we have to do it together. So I speak a lot, as much as I can, at national conventions or fundraising events, because I want people to know that change is on the horizon, but that we have to do it together. It's no single person's job, even if they dedicated 100% of everything on finding a cure. We have to do it together.
If someone in the audience here, and I don't mean to put you on the spot, but if someone in the audience here hears this and is motivated to consider learning more and potentially, putting their philanthropy towards pediatric oncology or neuro-oncology, what resources, where would you refer them?
Yeah, we have fantastic philanthropy offices, both at Boston Children's and Dana-Farber. I'm the Brain Tumor Center Director of both, which is really great because it now includes more labs, right? And the more people, the more ideas we will have. So if any of you is interested, please contact either me. I'm sure Trey will get my contact information out, or over via my website of the Philbin Lab. There's many other ways. There's also probably great advocacy groups in your community. If you feel very connected to someone in your community who has either suffered a loss or is fighting the disease, please also consider donating to them, or to many of the other runs and marathons and golf tournaments and walks. There's many ways to get involved if somebody would like to.
That's great. Google is a powerful tool and can help guide you. What are you looking forward to as we wrap up here, personally, professionally, over the next couple of years?
So professionally, I want to see the first 2 drugs coming out of my lab going into clinical trial and being successful. The first one is already on the way, and I'm super excited about it, but I know it will take more than one. So we have a pipeline now established, and I just want to see as many drugs as possible getting into clinical trials and hopefully helping our patients. And then I'm growing my lab. Also, we're now about 15 people. But again, the power is in diversity. The more diverse ideas brought to the table from engineers, biologists, computational scientists, like, or everything in between, that's, I think, where the magic is, and that's where we will make the biggest impact. So I want to grow the lab a little bit more, have that impact, and on a personal side, I'm also just looking forward to many more fun days with my family where we ski in fresh powder, hopefully in Vermont this year, and being outside and just also enjoy our time together. That's mainly.
Well, we're excited to have you and your family up in Vermont. So I look forward to meeting you in person. Thank you so much, Dr. Mariella Philbin, for joining us today on Medical Matters Weekly.
Thank you very much. It was a pleasure.
I'll also thank Mike Cutler from CAT TV, Ray Smith from Southwestern Vermont Healthcare, Ashley Jowett from Southwestern Vermont Healthcare, and a special thanks to Kathy Arabia from the AYJ Fund for helping make the connection with Dr. Philbin. I'm Trey Dobson. Go out and find joy in everything you do, even in the face of adversity, and we will see you again next week.